All right, this video is going to talk about what we call the change of base formula. And the change of base formula is essentially a way to change the base of a logarithm so that you can now type it either into a calculator or possibly just work with it more smoothly. And first thing that I want to do is to show you where the change of base formula sort of comes from. If we think about our logarithms, right, a log base a of x, again, that base a can be really tricky. So we love it when logarithms are either a common log, right, a log base 10, right, of x, or maybe a natural log, right, log base e of x. You know, they're much more helpful, much more usable as far as the calculator goes, right? So what we need to do is have a way to kind of convert, right? Since log base a isn't necessarily typable in every kind of calculator or every type of software that we use, how could we take advantage of, again, those more useful common logs and natural logs? How can we get rid of that base a and make it something that we can sort of calculate much more simply? Well, if you have y equals log base a of x, I'm going to do a fairly simple move. If you're familiar with solving exponential equations, basically you can cancel a log base a by exponentiating, right? A to the power of log base a will cancel away. If you're not familiar with that, maybe you're more familiar with sort of the swirl method, basically saying that the base of a logarithm would be raised to the exponent of the other side and then equal to what's inside. So basically we would say a to the y is equal to x. Well, that's very helpful, but what we need to do then is use some logarithm properties to sort of make this happen. And what we know about logarithm properties, again, if I take the log of both sides, so I'm just going to go ahead and put a logarithm on both sides of this equation here, we have a property that says we can take the exponent, right, inside of a logarithm, so this y that's up here, and we can pull it down in front, right? There's a property that says that y times the log of a is the same thing as the log of a to the y. Right? So we get this statement then. And in that case, well, hey, if y is just multiplied by log of a, why not just divide away, right, that log of a, that common log of a, and essentially we end up getting that y equals, right, because on that left side that stuff's going to cancel away, y equals the log of x divided by the log of a. Right? So it's a base 10 there, and realize again at this step we easily could have used a natural log as well, right? We could have done that if we wanted to, or any type of logarithm really, but again, why would we use ones that aren't as helpful? But again, if y equals log of x over log of a, remember up top, y equaled the log base a of x. So really, this also equals the log base a of x, and these two statements are the same. So what that does for us is it says, well, hey, if we want to find log base 3 of 2, and I don't have a calculator maybe that I can type that base into, what we can do is just say, well, why not take the log of what was inside, so again, the log of 2, and divide that by the log, right, and use common log both times, of what used to be the base. And now, if I open up my calculator, right, if I open that up, I should be able to go ahead and calculate that number just by typing in some simple common logarithms. So here comes my calculator. Sorry, it's a little slow to open there. But again, we should be able to type in the log of 2 divided by the log of 3. Right? So I'm going to go ahead and get to my main screen here. And I'm just going to say log, right, common log of 2. Make sure you close that logarithm. I want that entire logarithm, right, divided by the common log, use the same one both times, of 3. And again, I close that one as well. And notice we get 0.631 approximately, right? 0.631 as far as that goes. So we can go back here and say, well, this is approximately equal to then 0.631, which makes sense. 3 to what power is going to give you 2? Well, again, we're going to have to do some sort of a root or fractional exponent, which again means something less than 1, right? 2 is definitely less than 3 to the first. So again, we got to have a power that's going to be less than that. Let's do the same thing on the other side, only this time let's use a natural log. So again, we're going to take the natural log of what was inside of our previous logarithm and divide by, again, the natural log. We have to use that same log both times of 6. So again, let's go ahead and go on the calculator. It should be a little faster since it's already open this time. And we can say natural log, right, of 12, I believe that's what we were typing, divided by the natural log of 6. And again, if you want to see that you really do get the same thing both times, feel free. You can do a common log instead. Right? Change that to a common logarithm as long as you use the common log both times. And you'll notice you get the same answer both times. 1.387, right, if we regularly round. So this will be approximately equal to 1.387. And there is our answer. Okay, if you have any questions about the change of base formula, feel free to talk to your teacher. Again, a huge advantage, as long as we're at it, is if you were going to go type in a logarithm and graph it. Remember, we won't be able to type in a log that has a base number on it, unless we have, use a fancy command like log base or something like that. But if we want to, if I want to type, let's say, the log base 2 of x, I can just say the log of x, right? And then divide by the log of 2. And it's as good as typing in, again, the log base 2 of x, which again, you could also do down here, math, arrow to the bottom of my list to get that log base idea, right? And we would do log base 2, of x. We've got to make sure I get inside the logarithm though, there we go. And now notice when we go to graph, there's our first line, there's our second line. You can see that red line just basically cover the blue one. It's the same equation both times, going infinitely up to the right and infinitely down. Remember, your calculator's not real great when it gets near vertical, but infinitely down right along that vertical asymptote. I hope that helps you again with evaluating logarithms. And again, if you have questions, talk to your teacher. Have a great day.